This is IBM Museum. On this video, I have the Model 80 Type 3 system laid out on the bench behind me. And I've got that open, got the Skycam peering down from above. And this is not because I want to. I wanted to get up my P70 system and show or have the lead-in of this CPU area from that machine. And of course, these Model 80s have just got to throw up all kinds of fits for me, not give correct planar IDs, and have other information. And what I'm referring to is when we ran through the system information tool on the system, and I've gone a little bit further. I've actually got the where I've added a Kingston what's called the DC32 data card, and that's the 32-bit bus. Actually has a miniature IDE drive, and I don't have any of the memory slots populated, but those are nice little multi-purpose devices that add the hard drive and memory to a system. And they don't like to cooperate a lot of time. I'm actually going through, and I have another hard drive and controller. I'm going to put in a Adaptec 1640, and that's good standard. I've reviewed that in a prior video, or showed it on the Type 2 system, and I gave a link in the description. But I'll have that loaded as my boot drive. I'm going to turn this into a little bit of development, or get to run some software on it, and maybe that'll give me a little bit more of the details to it. I do have the system information tool copied over on this system. Of course, I've got a lot of other stuff to... Okay, yeah, so I've got the C version, which is the latest at the point of this video. So let's go ahead and run that just to get into the section that I'm talking about. Okay, and we'll go down to the model and processor information. Now, at least on the Type 3, the planar ID was correct, so it has all this data populated. Now, for the processor, it has unknown, and below it has the megahertz speed of 25. Also flags the coprocessor as unknown, and then we saw that internal cache being listed as present. And so it's not showing the CPU information correctly. And Major Tom did once again did a listing, went through and determined further information. And in previous in the past, he had gone through and done the supported systems, or the ones that were recognized by the system information tool. And then he's gone through and he listed the adapters close to the same time after that were recognized. That really long list. We've seen some of those adapters recognized now. Some of those listed as unknown, please report, blah, 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 blah. But this third page of information now, he's gone through for the list of recognized processors. And just to go through, and the system information tool actually does a little bit of detection of the processor that's there. In the case of models, and it can actually update that list. It's not so much of a hard-coded affair. And I think he provided this list just to kind of knock down what I had said previously, that those values are hard coded. Well, it does go through and it does check for CPUs. I'll give a link to this in the video description, and we'll actually see a little bit of a breakdown of these items as well. Does he list? Yeah, he talks about where, and he's got the link up there, and I have to see what the link will go to. I mean, I'm going to go through and offer the page that I have, because I almost even went through and updated it earlier based on this information. But one of the CPUs or among the list is the IBM 486 DLC2, or a DLC CPU. And that's where IBM had a leading A in that CPU reset signature. I've talked about that previously. I'll cover that in a little bit more detail in this video. And then there's also a new value that's related to the DLC CPUs from IBM. And they had that first digit in the CPU reset just so their CPUs would not be confused with Intel. And IBM and Intel did have an arrangement for a time where IBM was able to work with the code mask of the CPU start from the 386 CPU. And that was a CPU that went through and introduced, later on split into the 386DX and 386SX. And IBM went through and modified that. That's how they came up with the 386 SLC. And that's the same as the SX 386SX CPU. Generally the same speeds. IBM had some models that had that SLC CPU instead of the 386SX. And we've seen some of those, like the Model 56 and Model 57. The 8500 series of those units in that previous video. 8556 and 8557. And they added the 386 SLC CPU from IBM, added an 8 KB of L1 cache on the CPU to increase the performance. One of the other unknown aspects of it is it's actually able to run all the 486 Intel 486SX. That's the unit, the 486 CPU without the math coprocessor on there. But it's able to run all those instructions on that IBM 386 SLC CPU. And there's a little bit of debate why IBM, kept it named as the 386 SLC when it's able to run 46 instructions. But IBM later on had the 46 SLC, still able to run those 46SX instructions, but also going through and doing clock multiplying internally, coming up with the 46 SLC2 that clock doubles, and 46 SLC3. And we've covered those CPUs as well in that same Model 56 and 57 video, the 9500 series, the 9556 and 9557. Had those CPUs, and that actually increased the L1 cache to 16 kilobyte, and of course with the clock multiplying, in particular that 46 SLC2, the 46 SLC3 is one of the fastest 16-bit data, 24-bit address CPUs that you can find around. I mean, it goes through and it's pretty good. And, on that chart, there is the recognition for that. We've seen those CPUs recognized when we've run the system information tool on those systems. But the DLC CPU is in here. And that's the CPU that I have on this Type 3 planer. And IBM even designed these for the Model 70 and Model 80. It's right down here in the center, and it's in the socket, of course, it's right beneath that bar. It runs the CPU is actually tucked down on the underside of that adapter. Just an amazing thing that it doesn't need any heatsink or anything else. When IBM even put a heatsink on the 386 SLC CPU, that big gold colored block that was on the 8556 and 8557 systems that we saw with that CPU. So why is this not reporting the CPU correctly if this is on the list of the supported models? And I don't know. I just had to dig, and I'd seen the system that I'm gonna have here later in the video, that I plan to have later in the video, the P70. I just looked over the machine, and Major Tom did some digging for me, and we discovered what was up with it. And I hope to lead in with it, because it actually has kind of a good side to it. This I just don't know. So one of the so what I can do is I can go through and I'll actually change the browser page that we have up, and I'll show a little bit of the detail of that, of what I've been working on. Okay, and this is how the system information tool and other software goes through and can determine the CPU from that CPU reset signature. We've covered this as it was on the Model 25SX, the Model L40SX, just showing those the cases where that and the 55SX where there's not a the value saved away, that CPU reset signature saved away in a location on the system or in the extended CMOS. In those ISA systems and the 55SX, we saw that being stored in what's called the EBDA, the extended BIOS data area, instead of extended CMOS, and had to kind of locate things down there. But this is the decoding, and I meant to even go through and add a little bit more to the 46 DLC from IBM. I've got information on, yeah, and that's another update I have to do. And as I say, I was thinking of doing an update a little bit later, or tonight, and I just ran out a little bit of time in front of the video. But I'll have that updated. But you can see at the bottom there's the IBM 46 SLC and the codes that it gives. Now down below, and I list some alternate ways of getting the this value from the system, depending on what it is. And the notes, I say, oh, in fact, that's why I didn't see some of the updates. Okay, give me just a moment. Okay, the reason I had to pause the video is that page has been updated. My web browser pulls it up as the updated page, but OBS, in the OBS weirdness of the world, is even pulling up the page that I last updated or last November when I updated it. And I had to actually set OBS to use a local file so that I could go through and have the proper updates. And this is a little bit more better filled in and I don't necessarily know if I've gone through. Yeah, I don't believe I've updated it for the possible DLC a leading 8 that they can have that I saw from Major Tom disassembling the list of processes that are recognized under the System Information Tool. But I was wanting to get to the note, and so the BIOS has to save away that CPU reset signature. And most microchannel systems, as we saw, they go through and they write it to a location in the extended CMOS. The 55SX was the sole microchannel system that's a 386 class or above processor that uses the extended BIOS data area instead. And I'm going to go through and actually modify one of the 55SXs that I have, that I can make it into a 55LS, and I'm going to give it extended CMOS, and it will go through and start to use that extended CMOS for storing that the CPU reset signature away. Now, I do have further notes. We'll get to and bring this page up once again once we have the P70 unit up on the bench here. But at the bottom of this page, beyond the alternate routines that I have for going through and getting that from either the extended CMOS or the extended BIOS data area, then I have the list of models and where they store that information on the system. Now, I am going to have to update this list because we do have among these and I have all the Model 80s grouped together, and so I'm going to have to split that up because that Model 80 Type 3 does not save away that value in extended CMOS, and we'll take a look at that. But all the other models, I mean, I've got a pretty good list. I've even got the information on the P70. There's a talk about C notes or C note above, and I'll get to that when I have the P70 up on the bench. But let's go over to, and we have I've got the UNPC program on this system. Okay. And let's start up that, and I'll go through, and I'm going to be facing the screen so I just don't have quite that lag of information. So the CPU information here from the UNPC, it does list it as a 46 DX, and that's easy to go through and check. This actually has that DLC CPU does not have a coprocessor inside, but I do have a 387 DX on the planar. You know, you can see it with the white lettering, and that is probably even the multi-speed unit with that script type of lettering, to where that has the later core. It's actually a faster 387 core that's in there, and so that's why it's showing it as a 486DX. It's thinking that the math coprocessor is inside the CPU, or FPU inside CPU, as it shows there. And CPU instruction set, it's able to run 46 instructions. This is not from that interrupt 15 hex C9 hex function. This is just going through and seeing what runs, or what the system there's ways to differentiate between the levels of CPUs. But it does go through, and as a teaser, it has a CPU vendor of IBM. And so somewhere that CPU reset signature is coming into play and being detected at some level. And I'll have to go through and figure out where that value is saved and how. There are what they call model-specific registers that's on the CPU. They're on the 386 SLC, they're 46 SLC2 and SLC3. They're on this IBM 46 DLC2 CPU, and that may be a little bit of how it's detecting this as an IBM CPU. But I think that CPU reset signature is hiding somewhere. It's going through and detecting it. And I may have to look through the UNPC book and just to get a little bit of idea on that. Major Tom will probably go through, and if he has the time, he might be able to check to where that function, that interrupt call, is saving away the value, or excuse me, where the CPU reset signature is saved away on the unit. And it's showing the internal speed pretty close, 70 megahertz. It's a clock doubled chip. Has a little bit extra of that L1 cache. It brings it up in even above the Intel, like Intel DX 266 megahertz. These are a little bit faster for all that. But it says CPU version detection not supported in this BIOS or CPU. That is saying, as the way I understand it, that it's not supporting that interrupt 15 hex C9 function call. And so I looked through, and like I say, I didn't want to spend a whole bunch of time going through the Type 3 planar this way. We can look through the extended CMOS contents, get down to that microchannel, and I looked through this. I tried to scan through in the extended CMOS area. This is still a regular CMOS here. Get down to where we have the microchannel extended CMOS memory. And so usually on machines that have that extended CMOS, it stuffs that value into that 0190 and 091 hex values that are in. I can go through and get that kind of in the middle of the screen. We're looking in that leftmost column, that 0190, and the first 2 bytes that are shown there, and they just show up as zeros. So this is got a lot of other information here in the extended CMOS, but not the information that we're looking for. And I scanned through, and it should be something in effect of a A4, and then the third digit would be a 2, excuse me, because it's clock multiplied by 2 internally, and then the stepping value. And I looked around, I didn't see it. So I went through on the, just using debug, DOS debug, and went through to find the extended, and let me go through and populate even the zeros in here, just to kind of give a little bit more idea of the segment and offset that I'm using in that standard debug notation. We're going to do 16 bytes again, length, just like we did in that previous video. And I'll link in the prior video that I went over the 55SX, the 25SX, and the L40SX. So that's showing this kind of the more standardized location of the extended BIOS data area, the EBDA. So we dump 9FC0 for our segment. That's the EBDA segment. We start from 0. And we'll do a length of 160 in hexadecimal. Now, those other models they had in the location, like for the 55SX, it had that information stored in the offset 00B6 and 00B7. And there's just 0 values in there. The 25SX and L40SX, even though they had different EBDA segments, differed slightly, they had them in the 00EE and 00EF. And that's towards the a little bit of about the 2/3 down of the screen. It has that, in that left hand column, it has that 9FC0 colon 00E0, and we're wanting to look all the way over to the right to the last 2 bytes there, the EE and EF bytes in hexadecimal, and those are also zeroed. So I looked through the other information on this, of the extended BIOS data area, and I'm just not seeing, went through and dumped further information along, and I'm not seeing that information for the Model A Type 3. So it's going to be one of those things. I'll have to figure out a little bit of that model, and just these Model A's just don't make it simple. They go through, and I get more and more trouble from them. But that is we're still a little bit below a half-hour recording time. I'm going to do a quit to get out of the DOS debug, and we're going to switch things around, and I'm going to try and get up a model P70, that portable unit, and we'll look a little bit deeper at it in this regard. And okay, now I have the P70 up on the bench, and I've got it turned around. I've got the back cover off because just what I wanted to show of the planer, and also the kind of the connections, and an easy way to do this. Now, this is the same system that I had, that I talked about doubling the RAM on it. I had this adapter that I went through and installed. I wanted to pull this out to show what was underneath it. And of course, I had to go through and run the reference diskette for the model. What I've kind of settled into now, rather than getting into the bay, because you have to go through and pull out the whole thing, and to get access to these diskette drives are typically bad on the P70. I mean, all of my diskette drives are bad on these units. And when you have to run the reference diskette or something else like that, if you go through on the front of the unit and get at that bay, it's a lot of work, and not really so much work getting it apart, but getting it back together later on. And of course, you have to do that if you have a known working diskette drive, and this is a good way to check it as well, that I'll go over in a moment. You have to get in that bay, but the easier way is you go down here in this corner, And you do have to, there's one cable tie that is around where the power goes in, and there's some ground connections that have to be taken loose. But I'm going through, and the other end, the planar side of that diskette drive connection is right here in this corner, right above the input for the power cord. And so I go through and I undo these ground connections just to get access at that plug, and pull the drive that's installed in that bay, you know, the cable for that out of there. And I have a cable and a drive, my little go-to floppy diskette drive that I know works. It's got that standardized 34-pin connection for data and power on the back. I've been picking up some of these units off of eBay. The last one I got was actually $9 plus shipping. And I had, in that prior video, I had it in that bay and had it kind of strung over the top of the keyboard, and we were looking at the front of the unit. So this is the easy way. If you have to mess around with running the reference diskette or just any diskette activity, and you know that drive in there is bad, rather than getting into the bay in the front, go through and access it here. And of course you have to have a spare drive for one. And this is more a slimline drive. This wouldn't go into that bay without some adaptation. This is kind of like the L40SX drives that are in there. And you don't have to use the cable. I mean, I used a cable from another P70 that's right here, but these are just, it's a 34-pin to 34-pin. Even though it bundles the wire together just to get it through back there, you can use a 34-pin to 34-pin ribbon cable, and you know, there's ways to go through and get it the right keying. And on this cable, and you can probably use an example if you don't have the direct replacement for this cable. There is, the pin 1 is a gray connection, and that is actually on which end is that on? I'm just not seeing that with my glasses. Okay, yeah, looks to be over at this, let's see, I think it's over at this end. I took pictures and all, but the gray cable is the pin 1. This actually has the bump here on top and has the the keyway for and it has a shroud on the connection on the planer. And I mean, it's very evident. You can look at they, even though they wrap that cable in the bundle, the colors are all the same at both ends. So you can trace, it's a 1-for-1 transition for all those 34 pins. And I've already gone through and I've run the reference diskette, got the system configured without the memory card in here. Now this is the early, or it's considered the old P70 planer. And it's actually where the 20 megahertz model of the P70 came out first. And in this planer. And the main recognition is, of course, the CPU being here, and on the later planer, it's up in here, and there's the 2 EEPROM chips, and that 2 EEPROM chip is the old planer. The new planer, and that's actually a 16 megahertz or 20 megahertz planer. It has both, depending on the CPU that's installed, the oscillator circuit. Those are considered that newer or new planer, And you know, that's the easy way to recognize it. The 386DX CPU is up here, and it has just a single EEPROM chip. And I can include the link to that page. It shows the layout. Really, the planers are not otherwise all that different of layout, other than the CPU and the EEPROM chips. And the number of EEPROM chips is mainly the way to tell it. And I'm bringing it up for a reason. We do have the, I'm up to the command prompt. And probably what I can do, let me pause the video and I'll actually bring up the page of information on the P70. Okay, so here is the page of information at the Ardent tool on the P70. And I can link this in on the video description. And so scrolling down through kind of quickly, it talks about, you know, the new planer with the single EEPROM chip, the old planer with the two EEPROM, and both images are up there. And so it's not even a simple swap of EEPROMs between units either. One unit, you know, one planer type has that single EEPROM chip and one has two. So scrolling down, and this is the old planer, and it shows the two EEPROM chips up. It's the same aspect, you know, as we're looking at here from the back. The two EEPROM chips and the CPU and the FPU positions on the board. Lower down, there's the plasma adapter, you know, the plasma display adapter. And here is the new, the EEPROM is actually moved. It's that ROM that's located over to a little bit more to the right, below the riser slot for the P70. It says ROM on there. You can read it. And then the CPU, the 386 DX CPU, is up in that place where the two EEPROMs are on that old planer. And so, you know, that's the difference between the two planar types. And, you know, so let's get back to looking at that information on the CPUs in those. Some of my, a couple of my P70s, I actually have a later CPU in there. This unit, it's a stock CPU and stock NPU. So, or floating point unit. Okay, and I've got the keyboard wrapped around here to where I can face the screen. And we did run through the, I think we'd run through the system information tool. In fact, let me do directory just to see. Yeah, we have the B version, and that's fine for this model. Okay, and the credits for Major Tom listed there for these patches. Okay, so we're looking at the model and processor information, and it does identify it's the IBM PS2 model P70, the it being the 80386, that meaning a DX CPU, 386 DX, 20 megahertz, which is correct. It's got the 8387 math coprocessor, or FPU, floating point unit. There's the model of F8, the submodel 0B, BIOS revision 00, that BIOS ROM date 01, or the 18th of January 1989, and the planar ID correctly identified of FFAF. Now the other So this is identifying the CPU correctly. It's probably going through some other steps though. And the other new planar for the P70 being at 16 megahertz and 20 megahertz units for that planar type goes through, and it does have a different planar ID. That's why on that chart of supported models, the P70 actually has that that planar ID zeroed out. It so it doesn't act on it. It actually looks at both models or brings up the information for both models. Since they're different planar ID, it doesn't get locked in where it needs 2 entries or anything like that. So, and that has a slightly newer BIOS state for that planar version with the single EEPROM chip. So, and I'm going to go through and run the UNPC program, the dock UNPC program, to look at more of the CPU information. Under the system information, we have that CPU information. Okay, so a little bit like the Type 3 Model 80 that we looked at. It has a CPU. In this case, it's identifying it correctly. 80386 with 80287. That's incorrect. The 80287 is incorrect. That's just what the UNPC program has for a little fault or a bug or whatever. It is a full 387DX floating point unit, FPU, that's installed on this. The CPU instruction set of being a 386, it's an Intel CPU, and that's correct. Internal CPU speed 20 megahertz, just like we saw in the system information tool. That CPU version detection not supported in this BIOS or CPU. Okay, and so it's not supporting that interrupt 15 hex function C9 hex, where it looks up or gives it that interrupt call to get information about the CPU. And so I had to go back to this local copy that I have on the machine, since OBS software is not refreshing for the browser capture side of things, and going through and interacting with the page, and it shows the return values that you get from that interrupt call, but down towards the let's go down to the model where we have the P70, and I've kept it as one unit here. I don't distinguish between that old planar and the new planar, but I say it's extended CMOS 0190 and 0191 hex C note. And so in the note up above, I do have, and I had to read the little tiny letter, in the PS2 model P70 with the old 20 megahertz only planar, having the BIOS EEPROM pair, and then I give the FRUs for those chips. Does store the correct values in extended CMOS, but does not support interrupt 15 hex function C9 hex. That's what I'm saying. With the UNPC program, we can see not supported in BIOS or on the CPU. And on the CPU, it's talking about the later CPU ID instruction that Intel added in 1991. Any later, any of the 46 level CPUs that have that later copyright date are able to run that CPU ID on the fly. For the BIOS angle, it's talking about that interrupt 15 hex function C9 hex. So I notice I do say that is the correct values are stored in extended CMOS. And so going through and looking at the extended CMOS ROM contents, or actually all the CMOS contents, we'll scroll down to all the way through all this regular CMOS area. And we'll get into the microchannel extended CMOS. Okay. Keep scrolling. Get it up about the middle of the page. I had to make sure that I had my lapel microphone off since I swapped in the P70. So I'll have to review the video and make sure I've got good audio. That's the one thing of a wired mic, is I have to remember to re-hook it up to my lapel. But we can see from that over on the leftmost column that 0190 and the first 2 bytes there, that 0305, meaning a 386DX, and with a 03, and the 05 meaning the stepping. And so we have, for the decoded area, we have that at the very top of that, and that CH equals 03 hex, meaning the 386DX class, and then CL equal 05 hex is the D0 step of that CPU. So we know that that is a 386DX with the D0 stepping of the code mask. So a later version of that 386DX CPU. So the P70, even though it doesn't support the interrupt call, it saves the values away to that extended CMOS correctly. And when I worked with Major Tom for him looking into things, he has one of the P70s with the new planar that with that single EEPROM chip, and it supports the interrupt 15 hex function C9 hex on that system. Just the old planar with the 2 EEPROM chips doesn't support that function call, even though it has the stores away those values. So just one of those little differing things again, to where these models have all these little idiosyncrasies that I'll have to line up. And I have been with the Model Lady Type 3 planar. I'm putting the pieces together for making that development system to get into where I can do my version of the system information tool, both for a Windows version and DOS version, and got looking at the code, get transferring files over. And that's what I'm in process of doing, is actually starting to work with that again and get a version that'll incorporate all these little nutty things. And you know, if the system information tool fails to show the correct information, I can code for that and make it my version a little bit better. So that is all I have for this video, just showing some of the layout behind the scenes of the CPU information. And I'll have to figure out on that Model 80 Type 3 planar, and I'll probably have to have Major Tom's assistance in a lot of that to catch him with a little bit of a free moment for him to look at that a little bit more and figure out what's going on or where it stores that value. You know, I'll have to code for those differences or figure it out some other way. If you enjoyed this content, this off-the-wall content, click on that like button and subscribe to my channel. You'll get notifications when new videos come out. I'm still at that fast-paced schedule. I'm trying to churn videos out almost on a daily basis. I turned out 2 of the shorter video and a little bit longer yesterday, and that's just encompassing for tomorrow. I think I'll be able to do a video, but I've got something scheduled otherwise, so we'll see. But that is all I have for now. This is IBM Museum. Thank you.